Okay, paper 2, 11, part A. We'll go to a calculator page and we're going to define our function, which is got currently unknowns of x and k. And we're going to define that by pressing Control Template and then press the template button again and choose the piecewise function icon, which is that one there. And I'll say, how many pieces do you want? Well, we have to some extent 4 pieces because we've got below 0 as well as above 5. So I'm going to increase that up to 4, and we're going to put it's a 0 when x is less than 0. So Control equals will give us less than 0. We have the value of k times x. Remember to put the multiplication sign in, and that's between 0 less than or equal to. So Control equals less than or equal to x. Control equals less than or equal to 3. The next bit is 3 times k. We don't need the multiplication there. It knows that letters and numbers do always multiply. So that'll be 3 less than or equal to x less than or equal to 5, and 0 for x being greater than 5. Control equals giving us all these other equality signs. So that's just defining our function. Now what we're trying to do is find the value for k. Now the value for k will be the one that makes the total area under this probability distribution to be equal to 1. So I'm effectively going to do an indefinite integral. So press the templates button again, go to the definite integral. I can just go between 0 and 5. I'm confident enough that the values out with that will be nil, and I'm going to type in my function, which is p x of k, close the brackets. I'm going to integrate it with respect to x, and I want this all to equal 1. Notice I had to press right to get out of the integrand template before I pressed equals. Now when I press enter here, it'll give me an error because it doesn't know what k is, but if I now choose the nsolve command, so menu, algebra, numerical solve that equation for k, it gives us a decimal. It's not immediately obvious what that decimal is, but let's see if we can turn it to a fraction. I'll do menu, number, approximate to a fraction. It gives us that. Again, that doesn't look particularly nice. Often this is because I'm just going to press up, up, and then press enter. The accuracy value is way too big. I find that dropping it down to about 8 is normally sufficient, and we're confident now that k is equal to the value of 2/21. So let's just define that to be the case. K is Control Template equal to 2/21, and so now my function for k is well defined for a particular value. Now to work out the variance, what I'm going to have to do is I'm going to make use of the formula that the variance of x is equal to the expectation of x squared subtract off the expectation squared of x. Alright, obviously there'll be capitals there, but that's the expression I'm going to use here. So the expectation of x squared will be a definite integral. Let's go back up and see if I can reuse some of my earlier calculations. So that expression there between 0 and 5 with an x squared in front of it being multiplied in, that'll be my expectation of x squared. I'm then going to take away, whoops, we need to move outside the integral, take away, and I'm going to type in another integrand. Let's just paste that in. Take off the equals 1, and the expectation of x will just be x times that, but this whole expression will be squared. So the value of k has been defined to be 2/21. This section here is the same as that section there, and this section there matches that one there. So when I evaluate it, I get an awkward decimal. Again, let's see if I can convert it into a fraction. Menu, number, approximate to a fraction. Nothing particularly nice there. Let's see if I can reduce the accuracy a little bit. Let's go down to 8. Still not looking nice. Let's go down to 7. Just edge it slowly. That's looking a little bit nicer. Obviously all these decimals are a bit of approximation, and if you've done it as an actual fraction, if you leave it as a fraction, you might be slightly out. The final answer has variance to be about 1.38, so you could just leave it as a decimal to 3 significant figures and not get too worried about giving an exact value. And finally, for the median, what we're going to try and solve is, let's just go back up and recycle our integral expression. The median will be when we find the point that is halfway through the distribution, so 0.5, and I'm just going to find the value of t, the upper bound, so that the area under this curve satisfies this expression. I'm going to press enter to get an error, so I now know go to menu, algebra, numerical solve that expression for t, and it gives me the value of 3.25. So 3.25 is the median. And 11 part A is done.